Hi everybody, welcome to chapter 4. We're doing quadratic equations. You may recognize these, of course. We did them in the functions. Now it's just they're going to be basically equal to 0, and we're going to be doing a lot of solving for x in a different number of ways. So some of the big ideas: students will understand information from quadratic equations and the graphs of quadratic functions and how they can be used in areas like physics, calculus, engineering, architecture, sports, and business, like mentioned in the last unit. By the end of the unit, students will, or we should, find the basic shape and the characteristics of a graph of a quadratic function. Quadratic functions and equations relate to real-life situations, and solve an equation means to find the roots, the zeros. So let's start with 4.1. So it says graphical solutions of quadratic equations. So you may recall from chapter 3, here's some important information. It says a quadratic function is a function f whose value f of x at x is given by a polynomial of degree 2, which is a quadratic. We'll do some more polynomial functions in pre-cal 12. For example, f of x equals x squared. That's the simplest form of a quadratic. That's our base function. That's what we have done with all of our transformations up to this point. And a quadratic equation, what we do is we set that equation equal to 0. So the function is when we have the y equals. The equation is when we set our y value equal to 0, or the equation is equal to 0, or a different value. It can be a number of different cases. And obviously a can't be equal to 0 because then we wouldn't have a quadratic. We'd have linear, because that would get rid of the x squared term, leaving you with a linear equation. The roots of an equation is the solutions to an equation, and the zeros of the function of the values of the x, which f of x equal to 0. Okay, and that's related to the x-intercepts of the graph, as you guys are aware. So these are some of the strategies we're going to learn to when we're solving for x. We're going to use graphing, the corresponding function. We're going to use factoring, completing the square, which we learned in the previous chapter, and of course the quadratic formula, which we did a lot of in Math 11. We've used the quadratic formula. So let's look at the first two examples. It says graph each of the following and determine the x-intercepts. All right, everybody. What we're going to do is to calculate the x-intercepts from the graph. I'm going to use the graphing technology, the graph calculator, and I will I get a nicer picture with Desmos, as you guys are aware, so then I'll bring that in for my graph. So I'll show you both, essentially. So what we're going to do is, I got to clear my other graph. So remember, when we're clearing that graph, if you do recall, it's second function, mem. We do 7, 1, 2, and that'll clear your graph for you. Okay? All right. Here we go. So I'm going to put the graph in as given, y equals, and you have in front of you have x squared x squared minus 8x plus 5, like graph. Notice you have that nice graph. And to calculate the x-intercepts, as you guys are aware, we had second function calc, 0, hit enter, left bound, we go down. Make sure you're on the left side, so on the way down the quadratic, that would be above the x-axis. Hit enter, down. So remember, we go right on your curve. Hit enter a third time, and there's our value, 0.6833 and 752. Do the same thing for the second one. We hit calculate and 0, and we go, and we keep going to the right, right, right. Now this time we're going to be underneath for the first one, or to the left, enter, and we go right, go above, hit enter twice, and that'll give you the second value with 7.316. So I'm going to use the Desmos program to do the same thing there. Start graphing, plug in your equation y equals, you can put f of x equals as well. It doesn't make a difference. Remember, we're setting that equal to 0, right? to get that, and I'll show you what I mean by that in a minute. On the graphing calculator, it's difficult to do, so I'll show you in Desmos as well. Minus 8x plus 5. There's your function. Make sure that's in your window so you can see there. You can just zoom in and zoom out when you're using Desmos, right? And you can set it equal to 0 as well. It's kind of neat what happens. It just sets your, it's pretty cool. But we like to show y equals for our graph. Then we'll click on our two values and the same ones that we obtained from the cut that out. I'll put that in your key so print those notes out for you at another time. And there's your graph. Underline the bold. And that's all you need to show. When you're graphing each of the following term x-intercepts, you'll do what I do in Desmos. You can do a nice sketch like this, putting some of the key points in. And there you are. And of course the other key point is plus 5. That's given by the y-intercept. And of course these are in standard form. We'll do the same thing with the next function. So in the second example, y equals negative 2x squared plus 12x minus 10. Take our graphing calculator again. We'll just go y equals. We hit clear. So we'll clear that out. We'll re-enter our equation. Negative 2x squared plus 12x minus 10. Remember, make sure you use the negative sign. It's down to the left of the enter, not the subtraction at the beginning. We'll graph that. And we have a nice graph opening downward, of course, because of the negative. And the x and y intercepts, these are right on the line, you can tell, but still calculate them. Calculate to 0. Second function, trace, which is calculate, enter for 0, left bound. We hit enter, above or to the right, hit enter, enter for another time, it's exactly 1 and 0. Second function, calc, 0, enter, go across, all the way down, oh, a little bit too far, hit enter, enter second time, and enter for a third time, and 5 and 0. Again, you could have factored that. This one is one we want to factor, but if it has to graph, just simply graph it like that. So I'll bring up the Desmos again, just so you can see. So we'll change this to negative 2x squared. Again, me being lazy, plus 12x minus 10, subtract 10. Here's our graph. So this a little more. When we click here, we can click and we can clearly see that these are our x-intercepts. Cut. And then we hit calculate. There we go. And bring it over. There's your graph. So I'll give you. I'll always have the graph paper there for you, or a quick empty grid for you. And there's your two graphs, really nice. And that's all you need to do is you clearly, don't worry about this gray dot here, this is just the y-intercept. But clearly label your two x-intercepts and your point, your coordinates as the x value and then 0, because obviously that's what it is. When y is equal to 0, your x values. But when you're plugging them in, you need to plug the equations, the functions in, y equals in your graphing technology, or even your Desmos there. That's what your curves look like. So you sketch your curve. Remember, your vertex will help. I recommend a vertex point and some other points as well when graphing. That'll definitely help you. So like when I go back to Desmos here, do the vertex, do your y-intercept, and maybe a couple other points if you wish. That are nice points. Like 2 and 6, for example. 2 and 6 are clearly on the graph there, right? Like I said, the more points, the better. And the other one here is at 4 and 6 as well. 4 and 6 clearly on there, right? So you can click. Right. Lots of points. Anyway. You guys get the drift. It's not our first time graphing, right? And there we are. And there we are. We got our graph. And sketch as many points as you want. It gives a nice clear graph through. Okay? Next example is solve each of the following quadratic equation by using a graphical approach. So again, just another question, gets us to use the graphing there, right? And the first one, we have 4x squared minus 12x plus 1. So remember, when you graph it, you have to set it equal to y1 on your graphing calculator, or it will not work for you. So it's y equals, clear this existing equation, with 4x squared minus 12x plus 1. The graph is going to be opening upward. Very nice. Okay. And find the x-intercepts the exact same way we did them before. I won't go through that again in the interest of time. So I use my Desmos program, which is great. And that's y equals 4x squared minus 12x plus 1. Function here. And a couple of key points, and there they are. Again, you guys know how to do it on the graphing calculator by now. And there's your sketch. So we hit, there we are. Get rid of that graph, and I'll plug the one in as our information that we want. Right. The Desmos is a very nice program. Zip the graph. Like I said, put a few key points in the vertex. I guess I could have put the vertex in as well for you. I'll do that now. Vertex is there. It's 1.5 and -8. You know, 2x intercepts a point and a y-intercept. You know, it's enough to get through the curve. At this point, we should be getting a little better at our curve sketching, for sure. And there we are. There's your first curve, right? So you put your coordinates in, a few points. You know, I have at least 4 points there. You need at least 3 for a quadratic. All right, your 2x intercepts your vertex and curve through. Remember to put your arrows up here. They do continue up and to the left and up and to the right. The Desmos program doesn't allow me to, or at least I don't know how yet. The next one is an interesting. So there's two. You notice that there's 2x intercepts here, right? In this one. So I've tried to create a scenario that similar to what we did in the previous chapter. Get some more information. So let's take a look, and we'll go to Desmos again for me to graph that for you guys. This one here is it's a nice one. It's x squared minus 2x plus 1. It's actually a perfect square trinomial. Notice it just comes down and touches. I'm going to add a couple other points in here too. I'm going to label the point. You can clearly see that it's -1 and 4 right on the line there. Hit label. And then I'm going to do another point here. The one that's 2 and 4, sorry, 3 and 4. You can clearly see that was off a bit. And so we got graph. I'm going to zoom it down a bit. There we go. And grab a quick clipping of that. Got it. And there's your other graph there. So this one only has one x-intercept. Remember, this is when we graph this, it comes down. This is called a touch. This is a one x-intercept, or some people call them double roots, or it has a multiplicity of 2. And we'll learn that in pre-cal 12 when we talk about other polynomial functions and their multiplicity. The last one there, I'm going to do that quickly in the interest of time. We'll do one more here for you, and we'll plug that in, see what we get. So x those 2 points out. So the equation is 3x squared. Remember, we have to y equals in front again. What has to be y equals 3x squared plus 10x plus 9. There's your graph. And this one here, not a whole lot of good things we got to do here because it is just comes down. It never has any extra intercept, right? So you can do a little quick sketch of that, do your vertex, and then go from there. But yeah, that's it. And we'll see you again in the next video. This one will be ready in the next video. Thanks.